We have 4x plus 7. This is minus 4 going in here, so we minus 4x.
They have to multiply this, the 4 and the 7.
Thank you. I got ahead of myself. Minus the 4x, 4 times negative 4, so we have minus 16. Four x's are going to drop. We get 12 minus 16, which is, what, 12? I see. 28 minus 16, which is 12. Subtract that out. You get a negative 4. Does negative 4 work? No. No, so it's extraneous because, the reason it's extraneous is because you get an undefined term in the denominator, so this is a no solution problem. Okay. I'll make Alicia's first, and she was 44, then I'll get yours next. Okay. 44 is eerily similar to the one we just did. The only thing that's different is that I need to factor the x squared minus 1 to write that out. So it's going to be, I have an x plus 1, x minus 1. Which means my common that I'm going to multiply everything by is? Very good. So the first fraction just needs the, excuse me, x minus 1. Is everybody okay with what I just did there? Yeah. On the other side. Since I needed to multiply that 2 by the x plus 1, x minus 1, I just went ahead and multiplied it by x squared minus 1. Same deal, just a little bit quicker. Okay? Combine like terms, we're going to get 3x squared minus 3x equals 2x squared plus 10. Send that over to the left, and we're going to get x squared minus 3x minus 10 is 0. Factor it out gives us the minus 5 and plus 2. We have 5 and negative 2 as our possible solutions. We check to see if they should work. Well, neither one of them becomes excluded, so it's just a matter of just substituting in. And I'm pretty sure I think both of those did work. It's 15 over 6, 12 over 24. They both, yeah. Okay.
Wait.
It's
How'd you
3
get
half.
the 12 plus 2x squared minus 2?
What's that?
How'd you get the 12 plus 2x squared?
Did the 12, since the 12 already had both parts of the common, it didn't need to be multiplied by anything. The last one needed to be multiplied by both of them. Well, both of them is x squared minus 1, so I just took the 2 and just wrote it real quick.
Okay.
I do that a lot when it's just a quick term that I can foil out in my head.
So 12 just stays?
Yep.
Nothing.
And you can't take the x out, so like you couldn't just leave it as x and then parentheses x minus 1. You can't do that.
No.
That's what.
No. Question on that? What was it? 42? Sure. Fraction equal fraction, so we cross multiply. So fraction equal fractions will have x times x minus 2 equals 3, x plus 2. X squared minus 2x, 3x plus 6. Send that to the left. What times what is negative 6? You add together to get negative 5? Negative 6 and 1 gives me zeros at 6 and negative 1. I actually was about to say move over or move along with it. Well, we're in a clown suit or a cow suit. I'd look pretty funny in a cow suit.
I think so. That's better.
No, doesn't match my eyes. What else we got? I didn't hear that. What's that, Russian? Melms, what'd she say? What'd she say?
Your tie doesn't match your eyes.
No, I know that. Well, I got green eyes though.
No, it does. I said.
I know it doesn't. I really don't. It looks Christmassy though. True.
Sure.
I can't hear you one moment. We're like twins.
Yeah.
What else we got? Alicia, what do you got?
46.
Sure.
I'm just trying doing it. I don't think it works.
Fraction equal fraction, we
Cross
cross multiply.
multiply.
Excuse me. So we're going to have x squared minus 3x, x minus 4 is 6x. So we have x cubed minus 4x squared minus 3x squared plus 12x minus 6x is 0. I just moved that 6x over real quick. Okay. X cubed, 4, let's see, so then we have minus 4x squared minus 3x squared is minus 7x squared plus 6x. What is your first rule of factoring? What's your greatest common factor? X. This is a part where on that quiz that we took a long time ago, when I had you graph via end behavior, most of you guys tend to forget that that value of x has a 0 at 0. So one of the possible zeros here is 0. So the other one is x minus 6, x minus 1, so we'll be at 6 and 1. But it can't be 0 because, dun dun dun, it is, what do we call it? Extraneous. Don't strain yourself. So 0 won't work, it's an extraneous solution. And then 6 minus 4 is 2. 2 over 6 is a third. 36 minus 18, 6 over 18 is also a third. Negative 3.
Yes, they do.
Yeah, they both work then. What else you got? 50. What are you going to multiply everything by?
X plus 1, x minus 1?
Yeah. What's going on, Dwayne? How are you, bud? Everything's getting multiplied by x plus 1, x minus 1, because that will be the common denominator in the long run. First one needs the minus 1. Next one needs the plus 1. Last one doesn't need anything. It's self-sufficient. And I just quickly moved the 2 over because I knew we were going to have to do that eventually anyway. Start combining like terms. We're going to get x squared plus 3x minus 4, I believe. What times what's negative 4 you had together to get positive 3?
Negative 1.
Negative 1, negative
How does
Four.
that
She's dressed him as a cow.
Don't be utterly wrong.
And they fart a lot.
One.
They produce a lot of methane. Are you
That's
producing,
mostly through
are you
burps.
producing a lot of methane?
Yes.
We were standing in line. This is great. We were standing in line, took the kids to go see Santa over at the little stand in Sycamore by the courthouse there. That was a great spot because there's never a line. And Ryan decided to sit there and just start making fart noises. So he's making, like just blowing all this crazy stuff, and one really sounded good. Guy turned around, he's like, I swear I didn't do anything. Ryan moves, he's just laughing, fart. So he's like being a ventriloquist throwing farts at people. You guys don't care. I thought it was very funny.
Does the one work?
What do I have to do about the one? Extraneous. So you just cross it out. Well, there is a solution. Can you divide by 1? Or what's 1 minus 1? Can I divide by 0? You just go back and substitute in. Well, I get negative. I get what's it? Negative 2/3 plus something. I did the math. Good marks. How do you know that? How do you know that it does work? Well, check it. Where's your work?
I think it's the last one.
It does.
Turned in. You know how the time
It doesn't work? Check your parentheses.
I might have done good.
Yeah, I
Probably done good.
Oh, I forgot that you
Yeah, I done good.
So you didn't do 48?
Should.
Yeah, I done
Don't done goof. Be done goofing.
Dang it,
I don't think it does.
Where's your calculator?
I don't know.
Do you think it might be a good idea to get moving to go get it?
Do I need it?
It might be move you to have it. Well, like you said, you move because they have hooves.
Yeah, it for sure works.
All right, the other things I wanted to look at then real quick is just kind of remind you guys and how some of this stuff works. What I did here is I made this little sheet, and I'll give it to you here. I'll give you guys a copy of this here in a second. Is that it has a bunch of just some quick review problems, and no, you will not have to graph tomorrow because you will get a dumb calculator. I'm just going to go through a bunch of junk with you guys here.
Good.
Okay, I just wanted to know, because like,
There's a lot of 9.4 will be good.
Yeah, 9495 is all kind of mixed in here. It's mainly towards the back half because the front half is just asymptotes and stuff. So one of the things I want to work with you guys real quick on is reminding you how you get your commons, especially when you're dealing with a complex fraction. For example, I want to pull and look at number. Did I send back enough in that last row? For some reason, I thought I might not have. Let's take a quick look and go over to 12 here. And I want to remind you guys on, also, when you're doing your work, you can always double check everything because I have the answers on the back.
I don't pay attention.
Yes, ma'am.
Are we gonna get another review after the final?
Yeah, when I make one. I usually,
Yes. Incorporate.
what happens a lot is, I'm kind of old school when it comes down to like breaks. I think they should be a break.
yeah, that's what
No, I know, but like,
But then also, do you want to?
What I have done in the past is that I will normally just email it out. I won't print a hard copy. So that way, if you really want to start looking at some stuff, you can just pull it up on the computer and go through things. Just because I'm trying to set this last week before we go to break to end at a spot that kind of works, all right? What's gonna happen is we're gonna start chapter 7 then Wednesday. We're gonna easily be able to get through 7:1 and 2, Wednesday and Thursday, and kind of tie it all together Friday. It's kind of all the same stuff, using radicals and fractional exponents and whatnot. When we come back from break, we have 3, 4, 5, I think 6 to finish out, which they all kind of work out to be the same. So what I've done, and this happened the exact same pace we were at last year, as I was looking at my notes from last year, is that we'll be able to finish out 7 without too much of a hassle. What I've normally done is not tested on 7. I usually throw like a little quiz in the middle somewhere, like a real short one, but then put the main bulk of the questions from 7 would be on the final. Does that make sense?
Yeah.
So when we get back from break, we've got that full week, and that's usually when I'm finishing out 7. Probably that last Friday is the day that we'll do a little quiz, a little short, something short with 7. And then we'll start the official review stuff that Monday, Tuesday. So that's usually what I work with these things to go through. We'll do half of the stuff we've done. We'll have done 5 units. We'll do the first half Monday and the second half on Tuesday. And it's just kind of like working through the packet, answering quick questions and whatnot. The test, the final itself, is all multiple choice. Okay? It is all multiple choice. It is all calculator. There is no calculator, non-calculator part of that. I have in the past thought about doing that, and I think it'll probably make more sense to do that second semester than it will first with the trig stuff. But we'll worry about that when that comes back. Obviously, the way the finals go, it's 3, 2, and 2. So yours will be that Wednesday. So you guys get to start off right away, woohoo! And then go from there. Can't believe it's already done the first semester. It's 60 degrees out. So one of the things that I try to get you guys in the habit of doing is when you're working with complex fractions, is to look at them independently. Look at getting common denominators basically twice. So what I'm saying is, I look at that top fraction and see, is there some common denominator that I have to worry about? Is there anything I need to do here? No. There's nothing that I have to do here. There's nothing that I can do here, so I just leave it. So then I look at the fraction on the bottom. When I look at the fraction on the bottom, I'm doing the same thing. I need to get a common denominator. So what's going to be the common denominator between m and a 4? 4n. So now, I put them together. Fraction on the left needs the 4. So 4 times 16, if I'm not mistaken, is 64. Fraction on the right needs to be multiplied by m. So I'm going to write it as 2m squared plus 5m. Okay? I just distributed it out.
Right, so even if it already has an M in there.
Actually, let me rewrite this here. Because I just made the mistake as far as the distributed property. Even though it has the m, but where is that m located though? It's up top, isn't it?
Yeah.
You're worried about the bottoms here. Okay. So now I distribute out the negative m, and I made that mistake because I went too fast. I tried to do too much at once. So now my denominator here is going to be 64 minus 2m squared minus 5m all over those. Excuse me. Now, that fraction that was up top, 8m plus 20, that I'm just going to rewrite. What I'm going to do now is just flip this, multiply by the reciprocal, because it's fraction divided by fraction. And I'm just going to rewrite in descending, so we have negative 2m squared minus 5m plus 64. Okay. And what simplifies? 1m. Okay. Now, the only thing that I can really check here is on this trinomial, if I take out a -1, I get 2m squared plus 5m minus 64. So I can try and see if I can factor that. Okay. I can try to see if I can factor that. But what would be the shortcut way to know if it's going to get me anywhere? Do you remember that trick that? The thing, yes, the thing. Yes, I do.
At least we know
Synthetic
what-
division. I know you're saying the thing. So if this is going to be able to be simplified, that means that something in here would have to be a factor of it. Do you agree? So what can I do to the 8m plus 20 to simplify that? Take out a 4. That means that if -5/2, and I synthetically divide with that, it gives me a 0, that means it's worth trying. Okay? Now, granted, it's negative, it's a fraction, but when you use synthetic, it's not going to be scary. So we tried -5/2. Oops. Drop the 2, and I'm going to multiply that out, I get -5, and all of a sudden I'm at 0, and it's not going to work. So, what that tells me is that I can't simplify it any further. Okay? It's a nice shortcut to see whether or not you can do anything. Okay? What we're doing here is we're using those rules from the polynomials from back in chapter 2 and trying to see if it's going to work. Okay? It's just one of those little shortcuts. All right? So then you're basically done. There's really nothing else that you can do. You've got your 4 times the 8m plus 20 over the m times the -1, 2m squared, 5m minus 64. And you can, I think the solution probably had it all multiplied out. So when it comes to the complex ones, a lot of times, because you're flipping things, it's not that big of a deal if you don't multiply them out. So you can leave them in terms in this case. Yes, ma'am. No, the reason I did that was just to make the synthetic look be a little bit cleaner. That's all. Just I thought it would look nicer. Okay, let's try another one. What's the other style that you guys just think is a big giant pain in the butt?
The whole thing.
Ah.
Every single one.
Let's look at 20. 20 looks scary. What times what's 8 you add together to get -6?
-4, -2.
So what are you going to multiply your thing by?
-4.
-4, k minus 4, k minus 2.
Okay. So everything's getting multiplied by that k minus 4, k minus 2. And you just go through each fraction. What is it missing? Well, first one,
K plus.
are you guys going to be mad at me if I use x?
No.
Okay. That one needs the x minus 2. The middle one doesn't need anything. Last one needs the minus 4. Okay. Now it turns itself into a giant FOIL and combined like terms. So we'll have x squared plus 3x minus 10. 4x plus 4. X squared plus x minus 20 on the other side. That's x squared 5x minus 16, I believe. I'm going to take everything from the left and move it to the right. What's x? 3. Break it into small parts. I don't think we've had a single one of these trinomials that the factors wind up being awful. I think every one of them has been pretty straightforward. I don't think we had any of them that had a first term that wasn't 1. Maybe if it was a 2, it's not that bad.
I have a question.
Yes, ma'am.
Okay, so like for this one, would it go to that this time or is it something like
Yes.
But like if that was like a 1, it would just be r plus 1, r minus 1.
Yes. Perfect, absolutely perfect. Good work.
Question right here.
What do you got?
Number 1,
Wait, pull it up.
I just need to see how it's done. Yeah.
Number 1?
Yeah.
Okay. Number 1, what happens here, now that you guys have seen the idea of solving for x by multiplying and getting rid of the fractions, a lot of times you guys tend to forget that when you are just simplifying what's called an expression, without the equal sign, you can't get rid of the fraction. What happens here is you have to get the common denominator and work yourselves out. So the common denominator here is going to be the 3x minus 5, 3x plus 6. Okay? So now the fraction on the left needs the 3x plus 6. The fraction on the right needs the 3x minus 5. From here, multiply and simplify out your numerators and leave your denominators as terms. So I'm going to get 18x squared plus 36x plus 18x minus 30. Combine them again. They're 54. And I do believe they have a common denominator. I'm sorry, not GCF, excuse me. 6. Just for argument's sake, to see if something can simplify, we'll take the 6 out, and we have a 3x squared plus, what is that, 7? No, 9. Duh. Is there anything that gets you negative 15 to get negative 9? Or positive 9? No. No, there's nothing. So now you're done. You just put this back over your common denominator of 3x minus 5 and 3x plus 6. And after you, correct me if I'm wrong, but you probably were thinking multiply it out and just get rid of them. A lot of times, if you don't see an equal sign, you can't do that. Okay? You can't multiply it because there's nothing on both sides of an equal sign that you can do that. So this is the example of you just combining your terms and put them together.
Your answer is different.
What'd they get?
6p squared plus 18p minus 10 over 3p minus 5 and p plus 2.
Oh, they GCF'd up front. It's, okay. What happens here is that you could take, they want a little bit more than we have to. Here, what do they have in common?
3.
A 3. So I can do this as a 3. What we did was fine.
Oh.
I don't think we've had a problem where they snuck a GCF within a term. It does happen, but it's not.
If that would happen on a quiz.
I'm not really worried about it, to be honest with you. I'm more concerned with terms going through. I don't believe I gave you anything that would have a hidden GCF within a term. Okay. Excuse me. Let's try another one. Let's try, which one? 24? Oh, how to do all the asymptotes and things and stuff?
Yeah. I don't know how to do that. I didn't even know how to do it when we were doing give it.
I didn't know. Same.
All right. So your x-intercepts are the zeros of the numerator. So I set the numerator equal to 0. And my x-intercept would be at 4. My vertical asymptotes are at the zeros of the denominator, so I set my denominator equal to 0. First rule of factoring is,
GCS.
which is x. So then what times what is positive 8? You add together to get negative 6. Which gives me zeros at 0,
0,
4,
4,
2.
and 2.
Which gives me asymptotes 0, 4, 2. Now, I know. This is that scenario that you will learn more about in pre-calc, where you could have an intercept on an asymptote, and it deals with the weirdness of those 2 degrees. Okay. Will there be a slant asymptote here? No, there will not, because
The bottom one's bigger.
the bottom one's bigger, correct. You'll have slant asymptotes when the numerator is 1 degree larger than the denominator. Did you know that you could have a parabolic asymptote as well?
What does that even mean? Let's learn about that later.
I don't want to know.
No.
Say we learned it.
Parabolic? Last thing we have to do is the horizontal asymptote. Horizontal asymptote, remember about the rules here. If the degree in the top is smaller than the degree in the bottom, do we have an asymptote, or where's it at?
0.
Was it at 0?
Or is it?
I'm gonna double check my notes. Yes, 0.
So it's small. The bottom's bigger than the top. 0.
Yeah, you only have that five.
If they're the same, that's when you play the coefficients.
Horizontal.
And that's what you're looking at being able to do. I'm not asking you guys to graph anything. I'm asking you to label stuff. That's it. No, because I'm not going to let you use your calculator.
It's A over C.
Okay.
So
I'm not reading. This is actually.
Are we going to get an equation in the H form or whatever?
I don't believe so. I believe everything was given to us like that.
Okay. So on the quiz, I messed up for that H and K. So I thought K was the vertical one.
Yeah. I think I left it like this. Here, we'll look at this one. This one's got a slant.
Slant.
What times what's 4 you add together to get 5? 4 and 1. So that means I have x-intercepts at -4, -1. Set the denominator equal to 0, and that gives me my vertical asymptote at 1. Now, will this one have a slant asymptote?
Yeah.
It does. Does it have a horizontal asymptote? No, because the top is bigger than the bottom. Now, to get the equation of the line of the slant asymptote, remember, you're using long division. So how do I turn a negative 4x into a positive 1x squared? Negative 4, negative 1/4 x. Very good, very good. Negative 1/4 x. Distribute that through, we're going to get negative x squared minus x. Yes, sir.
What are you looking for right now?
Slant.
Yeah, positive x squared, but just positive.
Thank you, I was looking at the wrong number. Okay. I subtract both of these, and this is where you guys will mess up. How do you turn a negative 4x into a 6x? 6/4, exactly. Negative 6/4, which is negative 3/2.
Oh my goodness, I can't do this.
So let's be 6x.
Why not?
Does it really matter?
What's that? No, you don't have to finish that. Once you get that, you're fine. But the only thing, like Noah was just saying over there, you have to simplify that fraction. 6/4 is, so your y equals negative 1/4 x minus 3x. And that's how you would find your slant. Okay. Remember, the trick is, when you're dealing with the fraction ones, you just, whatever that leading term coefficient is, that's going to be your denominator all the time. That's really about as tricky as that gets. It's tricky to rock a rhyme. That's right on time. It's tricky.
So,
What's up? Yeah, very similar. Remember how we had on the quiz where I just wrote this little blurb where they were? That's all you have to do.
so then how do you draw it?
No, you don't have to grab it.
We don't have to grab it.
No,
So it doesn't.
grab it. I'm just going to ask you where things are, that's all.
Wait, so you don't have to.
Yes. What else? Which other style you want to look at, guys? All right, let's do a division one. We haven't done one yet. Let's look at 18. Remember, when you're going to do these problems, you want to factor everything first. So I have x, let's see, plus 8, x minus 3. Negative 4 to me to get to positive 3, so that'd be x plus 8, x minus 5, x minus 5, x plus 4. What I'm doing is I'm flipping this fraction right away over 4 times x plus 4. You can. That's what I had to do here. Yes. Yeah. Sorry. Yes. Because if you didn't, you wouldn't be able to simplify out the x plus 4s. Because now, bless you, and then you're done. It's moving.
Huh.
I don't like it.
Yeah.
I like the problem.
So, x minus 3 over 4. That's the answer?
Cole, do you have one too?
Are you sure? Oh, no, I'm sorry.
No, please ask. No, because it's not you. You're the voice of reason for all these yahoos.
Looks like it's one thing.
They work like all the Yahoo. Oh my goodness. Ooh, I know.
What is it for? What is that?
Shoot.
Are we done? So is this whole thing over?
Letter.
For real.
So what's the quiz on over tomorrow?
Basically 9296.
9.2 to 2.96?
Or like a 9.2 and 9.2.
So we're not doing
9.2 to 9.3.
So we're not doing the variation stuff.
I'll throw that on the final. I know, the variation is pretty easy.
I know.
9.1.
What else you want to look at? We got a little couple more minutes. Another style, another question, another problem. You don't care. Nah, see, to be honest with you, this